and welcome back to Precalculus 1.
Hi.
On this glorious day. Our, let me see, section for the day is sections, yes, but we'll start one by one. 3.2, we're talking about logarithmic functions. Yes, it's going to be epic. First, let's review some of the stuff that you are hopefully familiar with. We'll start with 2 plus 3 is equal to 5. Now, we are able to use the opposite operation. What's the opposite operation of addition? Subtraction, very good. We are able to use opposite operation to retrieve any of the input numbers in this sum. So I can go and say 5 minus 3 is 2, or 5 minus 2 is 3. Guys, exam 3 is coming up, so pay attention. Now, we're going to say that repeated addition is multiplication. So instead of you going 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, plus 3 is 15, you would say 3 times 5 is 15. You memorize that. So, how much is 2 times 3? 6. What is the opposite operation of multiplication? Division. So we can use division to retrieve any of the input numbers, also known as factors. So 6 divided by 3 is 2, and 6 divided by 2 is 3. And now we say, all right, so we can also do repeated multiplication, and that's called exponentials. So now, how much is 2 cubed? Which is 2 times 2 times 2, that's 8. Now I can take a cube root of 8 and get 2. That's the opposite operation, right? Yeah. Of cubing, cube root. How do I retrieve 3?
You can. Or is it 1 over log something?
Very good. It's a log. Log base 2 of 8 is 3. Log is that missing mathematical operation that we are going to use to complete this chart. Logs are opposite of exponents as well as roots are, just in a little bit different way. And it's the only basic mathematical operation that doesn't have its, kind of own notation. It uses letters. So, people tend to resent it because of that. It's like something special. Guys, you have to understand logs are as good as addition, except you haven't dealt with logs, in the last 10 years of math. So it now looks like, ooh, this is something special. It's not. You have 2 plus 3 is 5. You combine these two numbers with the addition sign and you get 5. Well, you combine 2 and 8 with this operation and you get 3. Just like when you say 6 divided by 2 is 3, or 5 minus 2 is 3, well, log 2 of 8 is 3. So it is just mathematical operation. There is nothing special about it. It works in a different way than other operations, and obviously that's why it's different, right? And it's the only operation that really has letters to it. So, Mathematical Society was supposed to come up with some kind of symbol for it, right? Like, I don't know, 8 heart 2 is 3, I don't know, whatever. But the idea is that all it is just a basic operation, just like all the others, And you compute this using the calculator, just like you can all others, right? So now, I want to give a few of these examples of how to compute with logs, because, as I said, logs are just log is just operation to compute values. So how much would be log 5 of 125? Well, you would look at this and you would say, nope. You would ask yourself for this one, what is this exponent that goes in a box that will satisfy this calculation, and you know all it's 3, right? So that's why the answer is 3.
Oh, I get it now.
Awesome. Here's a spicier example.
Oh, let's go. Okay.
Is that 7?
That's a 7, yes. Yeah. The answer is -2. Yes. The answer is -2. Why is the answer -2? Because we need to have 7 to some exponent to be equal to 1 over 49.
And negative does.
Negative, yes, negative will go below the division line, and then square, 7 squared is 49. So the answer is -2. So when you're solving logs, it is technically this kind of guess and check method.
Can you do it on a calculator?
But for the most time, you will not be able to do this. So we are going to look at we're going to use the calculator to do these calculations. Now, your calculator will only have 2 bases for calculating logs. There are some other calculators, maybe some of those scientific ones will let you actually type in any base. But standard TI 83, 84 only speak base E, special base, and base 10. So on your calculator, you are going to find the LOG button, which is the log base 10. And you will find also LN button, which is the log base E.
So if I don't have the T,
So this is on your standard TI 83, 84 calculators. Now you actually don't need anything other than one of these logs, because there is a formula that you can memorize called change of base formula. And I will get into that soon. Let me just make some definitions first. So when I write log, let's say log 2 of 16 is equal to 4, I will start with saying that this number over here is the base. That will be the result. And that will be the power, also known as the exponent. And you can rearrange this formula quickly into 2 to the 4th is equal to 16. We said this is how we're going to compute when it's possible, using that, that where the 4 is, there should be a box there, and then you ask yourself what number goes here to get that answer. So before we do that, we do anything else, let's go with the conversion formula. Sense the tone of the title. What is the issue? I'm sorry? We are all good? All right. Conversion formula. A raised to B equals C converts into log base A of C is B.
We can't do that on a calculator. No, but he's saying that there's something that like you can do on a calculator.
Well, you don't need one. Why do you put the double one?
Except for sometimes you will.
So now, guys, this is, yes? This is why I have me. Yeah. In terms of money, I'm 3 times more expensive than a text. For history.
0.
Yeah, 3 times more expensive than a textbook.
Well, it's
Your textbook is what, 160 bucks? And I cost you 480, so there you go, right? Yes.
Why do you put a double line between the arrows?
Well, equivalency. That's equivalency symbol. So we can, guys, the reason is certain problems will be posed like this. You will have to jump there to solve them. Some problems are posed like this. You will have to jump here to solve them. So it goes both ways, this formula. It's equivalency between the two forms that will contain same numbers. So now underneath I will put the example 2 cubed equals 8, and then the one that we had earlier. Yes?
So it will always be easy enough to solve without a calculator.
Oh, hell no.
Like,
2 cubed is equal to 8. It's only easy when I pick nice numbers, but other than that is calculus 1 procedure to figure out whatever precision you want. But
in this class, we need the calculator.
yes. So here is the conversion at work. These two expressions are equivalent. One is written in exponential form. The other one is written in logarithmic form. They both have the same numbers. Obviously, those numbers are in different spots because in the first example, which is exponential one, 2 and 3 would make 8. And then in the case of log, 2 and 8 will make 3. So that's it. Now, what happens when we get to the... So make sure you know this conversion formula. Otherwise, there is no chapter 3 for you. That's as simple. Your chapter 3 dies with not knowing this formula right away. Now, what's the next formula? What's happening with log base 7 of 31? Well, there is no way to say, 7 to the 1 is 7. 7 squared is 49. Well, 31 is between 7 and 49, right? So it's definitely 1 point something. 1 point what, right? So we don't know the answer to this, and we also know that that answer is some kind of horrific decimal number. So how do we solve this? We are going to use something that is called change of base formula so that we can use our calculators. Change of base formula. And that formula says log A of B is division of log B over log A, or ln B over ln A. Hold on, I'm not done. Log x is actually log base 10 of x, and that is your LOG button on your calculator. And ln x is log base e of x, which is your ln button. So when you take your calculator, whatever kind of scientific calculator you have, by the way, I saw last night on the calculus exams that there are these, I think, TI 34 or something calculators which do not have e's and logs. So those calculators will be completely useless in this class, unfortunately, if you have those. So check. I think it's you. It looks like you have one. Let me see. Oh, you have.
Lit.
No, you don't need one. That's okay. So you have it. Okay, good. All right. So who's keeping? Okay. So guys, when you are on the TI-8384 calculator, which is the graphing calculator, your LOG buttons and LN buttons are on the left. If you're using one of the scientific calculators, there somewhere on the keyboard you will find them LOG and LN. Definitions are here. So LOG is always base 10. Now you have base 7 there, but that doesn't matter because if I use the formula, change of base formula, I can actually say that this is log 31 divided by log 7, which means you are using log 31, close the parenthesis, and then log 7. It's important to close the parenthesis. You must close the parenthesis after 31. So log 31, close the parenthesis, divide log 7, and you better have 1.7647. You will get used to getting 4 decimals for these exponents and logs. Very important to close the parenthesis after 31, otherwise stuff is not going to work out. Okay, so just make sure you put all of the ingredients you need, right? If you want to make a soup.
I was thinking more of a cake on the soup. Definitely. If it's cake, I like the soft
Cake is a lie. I was waiting for you to teach me.
What? The lie?
She would.
Let me be happy.
You just lost some points. It's okay. The rating went a little bit. So please calculate. I'm ignoring. Calculate log base 5 of 17, and let's calculate log base 3 of, I don't know, 91, whatever. It doesn't really matter. You actually have your cell phone, and if you turn it sideways, even Apple does that, you will get extra features. Even they figured out.
Do you know how to put it in now? Because I tried doing it. The log? Yeah. So like you hit the log and it says error. So
I think you first have to type in the number and then the log. And then you will have to write those numbers down, and then you will have to divide them manually. Here.
You can actually use that. Thank you.
and it's log friendly or the log pen button.
Wait,
Yeah.
can we use this on the desk?
You don't need it. You just have the scientific one.
So this would be
Yes, 4 decimals.
okay, get this right. I did 19, not 19.
Then it's definitely wrong if you did 19.
Yeah, Yeah, I did it right.
Sound like a bush over there. Now that we understand at least a little bit how to compute these logs, how to use the mathematical operation of a log, we are going to now talk about logarithmic function. So in order for, yes?
If I don't round on the test, will I get points off?
Yes. Okay. Well, I put it out there. Logarithmic function. In order for expression to be a function, right, we need that one-to-one assignment and all that cool stuff. But, you know, more, let's say, how should I phrase this? The words are escaping me right now. All right, I will have to rephrase these things. So, in order to have a function, you should have a variable somewhere, right? So we are going to first understand that our earlier calculation, 2 plus 3 equals 5, is not a function. That is calculation. There is even a school out there that says that arithmetic is not mathematics, it's just computation. Mathematics is starting with algebra, and then you can go on for another 20, 30 years after that.
Yeah.
Now, how do I create a function out of this? I replace either 2 or 3 with x, and then I make it a y, and all of a sudden it's a linear function. So how do I create a logarithmic function? Well, I will say y equals log, let's say, base 2 of x. And this would be considered logarithmic function. In more general terms, I can say y equals log base a of x, which would be the default state. That's a logarithmic function. Extremely good to know, because a lot of cool things are going to happen now. We are going to memorize the graph for logarithmic function that looks like this. The default case goes through number 1 on x-axis. It has the vertical asymptote on y-axis, which is x equals to 0. So when we take a look at the features, domain is going to be 0 to infinity, not including 0, so parentheses. Range is going to be from negative infinity to positive infinity, also known as this R, so you can use one or the other. We have the x-intercept at 1, 0. Y-intercept is none on the default case. Guys, I can move this to the left, and then I will have the intercept. So just, you know, these are the basic specs, right, out of box. And then you can modify it with aftermarket parts. And we have the vertical asymptote at x equals to 0. So these are the basic specs, and this is actually what you must know about logarithmic function. The rest you learned in chapter 1. Move it left, move it right, up, down, reflect on all axes, inverse of it. All of these other features of a function you already know from chapter 1. So now, this is new stuff which you have to memorize. This is how graph looks like, the default case, domain, range, x, y intercept, and the vertical asymptote. No horizontal asymptote, no slant asymptote, and so on. So now that we know this, let's go and once we know this, let's go and do what with the function? Shift it a little bit, you know, throw it around a little bit. Let's see how it behaves. So how about graph log base 2 of x plus 3 minus 1. How many transformations do I have? 2. Just. It's not humanly possible. Very good. The question is log base 2 versus log base 8. And all you're getting is they're all going to go through 1. You know. So no significance in terms of precise graphing, you know. Yes.
So like you just do like x squared plus, or like x squared is like your first graph. So would your first graph be like log 2 x? That was your first graph. Log base 2 x. So that'd be your first graph. Professor,
What happened?
how do you label the first graph?
Default graph.
No, but like
X and Y. This is
setting log
yeah.
base 2 x.
Yes, log base 2x. Yep.
That's where you just like label it as x squared. This is first. Okay.
And then you add the 2 transformations one at a time. That's a little bit crazier procedure. We'll get there. Are you ready? No. Well, too bad. Have too much fun in math class. This is Precalculus 1. We're learning logs, and this is really good atmosphere. I really like it. I just scared everyone. That student just got the problem correctly, and everyone is cheering for him, which is amazing. So the intercept point, which used to be at 1, is going to jump 3 units, yes?
You have to write it where it's, like, you have to say log base 2 x plus 1 x. You have to make it so it's if f of x equals log base 2 or y equals and does it not.
There we go. May use the proper notation. So what happened here is shift to the left 3 units, And note that the vertical asymptote also shifted to the left 3 units. That should be common sense. And now we're going to shift everything 1 unit down. Now, when you shift vertical asymptote 1 unit down, it actually stays in the same spot. And there it is. So this one is y equal log 2 of x plus 3. And the final one, y equal log base 2 of x plus 3, everything minus 1.
Minus 1. You're missing something.
What happened?
You didn't label.
I told you minus 1 point.
So did you really turn the stream off? Because I feel bad for the people that are supposed to be watching this.
You feel bad?
Not here.
Since when? Yes. I'm sorry? We will be computing those shortly. We are just now concerned with the general shape of the graph that should resemble the other lines as much as possible. For this particular problem, we can find both x and y intercept because we see them both, right? They're not necessarily 0, 0, right? They could be whatever horrible decimal they are supposed to be. So we'll see. Let's graph one more, and then after that we'll start computing these things as well. So let's say y equals negative log base 3 of x minus 1 plus 2. How many transformations? 3. So 3 transformations means 4 graphs, right? Default graph, and then 3 transformations, that will be 4 altogether.
But this reflects the X and Y.
Exactly. Exactly, Fred. Right?
Is the minus on x or minus y? Where is the minus? Yeah, I got it right. Not exactly. Yeah, no, I knew it was good. Right.
When they do this way, so you're right. So what happened? X-axis.
I know exactly what you mean. I erased yours.
It's already beat up.
Okay, let's take a look at this problem together. So I will need 4 graphs for this one. As the graph progresses, right, through different iterations. So we start with the default case. It always goes through 1. And then we are going to do reflection first. Since reflection is y, that means we are reflecting on x-axis, which means that the graph is going to look like this now. There's also an easy way to understand this, guys. Look, if you box off, I will erase this later, but if you box this off and say the whole thing over there is 3, well, then that minus sign would make it into a negative 3, so positive value 3 would jump down into a negative value 3. So that's how you see that it's a reflection on x-axis if you are carefully analyzing these things. So now we have a reflection. So this one would be y equals minus log base 3 of x. And then we can say minus 1. So that would be 1 unit to the right, which means that the vertical asymptote shifts into 1 and the x-intercept moves into 2. So now we have a graph that looks like this. And this would be y equals negative log base 3 of x minus 1. And now we need to shift everything 2 units up. So our vertical asymptote remains at the same spot. This one goes 2 units up. And we draw the same shape as before. This point here is 2, 2. And we are writing y equals negative log base 3 x minus 1 plus 2, which is our solution. It will. It will cross eventually. All good. All good. It's fine. Now, since there are questions about this X and Y intercepts coming in, we are going to now see how to compute X and Y intercepts. So say your equation is y equals log base 3 of, let's say, x minus 1. You want to find x and y intercepts. Where do you begin? Well, you know that if you're looking for x-intercept, you have to set y equal to 0. So you are solving equation 0 is equal to log base 3 of x minus 1. This is an equation. It has equal sign, and you have x as a variable that you can solve for. So where do you start? Well, we're going to use the fact that logs and exponents are inverses of each other. So we are going to use conversion formula which says a to the b is equal to c converts into log a of c is b, and we are going to use it this way. So now look what I have. Looking at this, a is equal to 3, b is equal to 0, and c is equal to x minus 1. Meditate on this. Do we all see it? When you compare the formula, which says log a of c equals b, compare it to all of the values we have. So base a is 3, the result is x minus 1, which is c, and b is the 0. So now we compile a raised to b, so that's 3 to the 0, is equal to x minus 1, which means that x minus 1 is equal to 1, right? 3 to the 0 is 1, and x is equal to 2. We found the x-intercept, 2, 0. We started with setting y equal to 0, so y coordinate is 0. So we have 2, 0 as our x-intercept. So this is going to be very straightforward and very easy once you get used to the conversion formula. So you start with this x-intercept, set y to 0, then just pick up your ABC, rearrange them, and compute. 3 to the 0 is 1, and you have basic algebra equation x minus 1 equals 1, which is x is 2, you're done. Yes?
So does that affect where you put it involved?
No. This is the final graph, has to go to 2, 0. To find y-intercept, we are going to set x equal to 0. So we are going to have y is equal to log base 3, what was the, of x minus 1. Well, now that's a 0. And what we get? Log base 3 of negative 1. No solution. We cannot take log of, well, we can, but we don't get the real numbers. So, guys, remember, always remember the graph for logs. See? Negative 1 is on the left. There is no function value for it. So this equation has no solution, which means no y-intercept, which actually makes sense because the graph is shifted to the right. So this line will be moved to the right and definitely doesn't cross the y. Yes?
I just have a question about the x-intercept. Wouldn't you know that it would be x, it would be 2, that would be log up, you know that x minus 1.
Oh, yes, you would. In this basic example that is just illustrating the principle. But this is usually the calm before the storm. So, yeah. So.
So what if it was like, what is x minus 1?
That's what the second example is for. Very good question. So let's have y equals ln of x plus 4 minus 1. We want the x and the y intercepts. Go. What is it? No, you know it. I said it already twice. What's the base for ln? E. So you get to rewrite this question first as y equals log base e of x plus 4 minus 1, since you are still learning how to do all of these things. So you rewrite it this way, and then 2.718281824590
Yeah, it's like 5.
3.14.
We're just math teacher in the period.
Y on the other side.
Does my only E button have an exponent thing on it?
Just put exponent 1. Oh, wait, where is it?
Like if I press second E.
There is an E without exponent right there, but this one is better actually to use, but that's it. Whatever.
Okay.
Oh, and use the. Why are you using log and then E? ln is the. You already have the ln button, but I don't think you're gonna need it.
Okay.
So for x-intercept, we set y equal to 0. We are solving 0 is equal to log base e of x plus 4 minus 1, from where we have that log base e of x plus 4 is equal to 1.
Stop. Why?
Because 0 plus 1 is 1. When you move the negative 1 to the other side, you have to have log. You have to have log alone in order to use the conversion. Conversion works a, b, c, and then log a, c equals b. And you see how log a of c, there is no plus 1 or something like that. So it has to be alone. So now a is equal to e, b is equal to 1, c is equal to x plus 4. Yes, e to the first power is equal to x plus 4, from where we see that x is equal to exactly e minus 4. Now you can use your calculator to find the decimals for it, if you really want to. And remember, always 4 decimals. So negative 1.2817. Depending on which calculator you have. So what is the x-intercept? X-intercept is negative 1.2817, comma 0. And now y-intercept, where we set x equal to 0. We're going to have our y equal log base e, but we can use ln, log base e of 0 plus 4 minus 1. So I'm actually going to plug in ln 4 because that's easier, which is 1.3863, and then we, is it minus 1? Yeah. And then we subtract 1 to get 0.3863. So what is the y-intercept? It is 0, 0.3863. So we are able to find x and y intercepts, and sometimes you're not going to have y-intercept. You always must have x-intercept. That one you have to have, because guys, realize that domain is from negative infinity to positive infinity, so it has to cross x-axis somewhere. But domain-wise, we have 0 to infinity, so it doesn't have to cross the y-axis. I'm going to write a very important statement and then connect that statement to the formula that I labeled as the most important formula for chapter 3. So I will say that exponential function and logarithmic function are inverses of each other. And I will write the conversion formula one more time. A to b equals c converts into log base a of c is b. This is a very important statement. Which leads obviously to this formula, which leads to us being able to find out all of that we need in terms of calculations. So what are the cool features of this? So first of all, let's go. Log any base a of a negative number is not real number. It's going to be imaginary, complex number. It will have I. So ln of negative 1 is pi I, actually. Yeah, but we're not going to do that in this class. Just telling you that you can figure out. Another thing that you should know at all times is that log any base of 1 is always 0, which should make sense because that's the default case, default graph.
So like even if it's like base 207.
Yes, even if it's base 207, it's still 0. Then the next one is that log a of a is always 1. So if you have same numbers, like log 3 of 3, log 10 of 10, log 206 out of 206.
It's 207.
I just wanted to be 1 up, so you were 1 up. That's why, but that's okay. Next rule, rule 4. Log a of a to the x is x, And this is where those
It makes sense.
inverses kick in. And the 5, a raised to the log a of x is also x. So these are the rules, and now we're going to take a look at these rules. Oh yeah, all of this stuff is on your class prep with a little sentence next to it, what it means, obviously. So I know that 100% of you understand this now, right now. Yes.
Number 5, is that a and then exponent log?
Yeah, log, the entire log is in the exponent. All right, so guys, let's talk about all these properties. So the first one is, well, you try it on your calculator, you will see, depending on which calculator you have, some calculators will give you the complex number as the answer. Some calculators will say error domain. So depending on what you get, but you cannot take log of a negative number and expect the real number, because that doesn't happen. Now, we know that the x-intercept is at 1, 0. Here's your x, here's your y. So it has to be that way. Look at this, AA. If both numbers are the same, so 3 and 3, or 206 and 206, then the answer is always 1, because that's the base, that's the exponent. So 3 to the 1 is 3. 206 to 1 is 206, right? So that formula also makes sense. Now, formulas 4 and 5. Formulas 4 and 5 are formulas that exist due to the fact that exponential function and logarithmic functions are inverses of each other. And we know that if we do the function composition of inverse functions, we get x on the other end. You should know that from your chapter 1. Remember how those 3 sections never go away, no matter which math course you take, forever and ever? So these two are due to the fact that if you compose function with the inverse, you get x, or you compose inverse with a function, you get x. So this is your function composition and inverses. So sections 1.7 and 1.8 together working to create this stuff. Now, what does that mean in terms of examples? Well, if you have log base 7 of 7 to the x, you just get x on the other end. Now, how would you prove that? How would you prove this? It's actually extremely easy to prove it, because all you need to do is to just use the conversion, right? Here's your A, here's your C, and here's your B. As soon as you rearrange this, you get 7 to the x equals 7 to the x. It takes less than a second to prove that this makes sense and it's valid. The second formula works exactly the same way. If A and A are the same, and they should be because it's the same letter, then answer is again x. And this is what ends section 3.2. I will ask a few more quick computation exercises to see how well you're doing. How much is log of 1,000? How much is log of 1,000? It's 3. You shouldn't be typing that in a calculator, because you can calculate log of 1,000 in 3 different ways. Log of 1,000, what can you do? You can actually fill in the base, because you know that anytime there is no base, base is 10. That is the default thing that you must memorize. So you will be asking yourself a question, what goes in a box to make this two the same? And obviously answer is 3. Or you can go and set your log base 10 of 1,000 equal to unknown value x, and then use the conversion. A is 10, B is x, C is 1,000, and when you say 10 to x is 1,000, it's clear that x is 3. So there are all of these different things that you can do to solve these logs. Obviously, you can take the calculator and do it that way as well.
On the test, do you have the calculator and non-calculator version?
Yes. And log of 1,000 is on the non-calculator version. All right, so I'm going to stop the stream now and restart for 3.3, where we need to learn 4 formulas and we're done.